hyperscale data center does dominate storage, particularly solid state storage. The data center being software driven, there are many opportunities that are yet to be addressed. Software-enabled flash combines the speed and flexibility of flash with the ease of software definability, with the objective of maximizing the potential of the flash that is already being deployed and will be deployed. Software-enabled flash fundamentally redefines the relationship between the host and the solid-state storage. It does that by giving the host unprecedented control over the behavior of the media and the device. In other words, it maximizes the value of the flash. Now, we do that through purpose-built hardware and a flash-native API. Abstraction is a key way that we do this by abstracting out the hardware functions that are listed here, as well as giving software abstraction to key behaviors. Isolation being one of those most important ones that we provide. Now, we allow isolation on two levels. One is through hardware isolation, where you can break up your quanta of flash into various virtual devices, and you can freely define what those virtual devices are. On top of that, we provide another layer of isolation, of software isolation, by being able to break those virtual devices into quality of service domains. Another key component is queuing, something that's very powerful in controlling your latency outcomes. We provided, as a default, 3 forms of queuing: priority queuing, round robin, or weighted fair queuing. The host has control over adjusting those weightings according to the need of the workload. Offloading is also something that's very powerful and important, and that's going to be offloading a lot of the media-related functions from the host. In the case of a write, once a write is assigned to a particular device, the software-enabled flash controller will scan the media and identify the most opportune or the most appropriate place for that data to be written to. We'll conduct that write and then return the address to the host. In the case of some of the low-level functions we talked about, such as garbage collection and others, again, the controller will offset from the host the actual execution of those functions, while allowing the host to be able to determine when to start and stop. Those that include garbage collection, wear leveling, compaction, and others. Finally, is the value to the business and the enterprise. One of the key objectives we have with software-enabled flash is by those who adopt the API to be able to fit with the most recent or the upcoming generation of flash. And an important factor in TCO is always being able to get onto that new generation of flash as soon as possible. If you adopt this API, you can do that because each generation of flash will just work. That will therefore allow you to reassign your resources to those things that are much more important to your enterprise. Finally, as you continue to adopt, or as data centers continue to adopt flash over hard drives, the ability to dynamically meet the needs of that storage to the need of the data center will really aid in maximizing the value of what's being purchased and what's being deployed.